Alright, humanoid robots are getting far too real. And this new one out of China proves we are entering a different phase. In Shanghai, a robotics company called DroidUp has revealed a humanoid named Moya. They describe it as the world's first fully biomimetic embodied intelligent robot. The wording is complex, but the idea is simple. This machine is not designed to look like a robot that happens to walk. It is designed to move, react, and exist in a way that feels human on a subtle physical and social level. Moya sits in that space people have debated for years, the moment when robots stop looking like tools and start feeling like artificial people. It is not industrial, not cartoonish, and not exaggerated. The design direction is realism without becoming a science fiction android. In videos that spread widely on Chinese social media and were later covered by the South China Morning Post, Moya maintains steady eye contact, smiles slightly, nods as if it is following conversation, and walks with a gait that makes you look twice. DroidUp says the robot can reproduce human microexpressions. That is significant because tiny movements around the eyes, cheeks, and mouth are what make interactions feel natural instead of stiff. It is not just about moving lips. It is about subtle timing and small muscle-like shifts that humans read almost subconsciously. Physically, Moya is built with intentional human proportions. It resembles an average adult in posture and structure. The internal build appears lightweight, suggesting careful engineering choices to support smooth and natural motion while avoiding a mechanical look. Another detail that pushes realism further is body temperature simulation. DroidUp says Moya maintains a warm surface temperature. When you are close to it or interacting physically, it does not feel like cold metal or plastic. It feels warm, closer to a living person. That warmth can significantly change how comfortable people feel during extended interaction. The company claims the walking posture closely mirrors human movement. Many humanoids can technically walk from one point to another. Very few move in a way where your brain stops analyzing mechanics and starts reacting socially, as if another person is in the room. That is clearly the goal. Online reactions in China were mixed. Some viewers were fascinated, calling it the future of companions, assistants, and service robots in daily life. Others felt uneasy. That reaction fits the classic uncanny valley effect, where something looks almost human but slightly off, creating discomfort. That tension is built into designs like this. DroidUp has not released a full technical breakdown of the hardware system, which has fueled speculation. There are reports suggesting Moya may use a chassis associated with the Walker series, typically linked to UbTech Robotics. So far, neither company has confirmed any formal partnership or shared platform. It could be a naming coincidence or an undisclosed supply chain overlap. What is known is that Moya appears to use a modular design. The outer appearance, including facial features and surface materials, can be customized without redesigning the internal mechanical platform. This flexibility is important for commercial deployment. Different industries, from healthcare to education to hospitality, may prefer different levels of realism and visual style. DroidUp is clearly positioning Moya for environments that require long-term human interaction and social presence. It is not being marketed as a warehouse robot or a stunt-performing machine built for viral videos. The focus is social engagement and integration into human spaces. While Moya focuses on realism and emotional presence, it represents something larger. It signals a shift in robotics, from machines that simply perform tasks to systems that occupy social space. It is not about strength or speed. It is about subtlety, comfort, and psychological impact. For decades, much of the Western world viewed China as a factory of cheap imitations, a country known more for copying technology than for innovation. But while most people believed this, something very different was happening behind closed doors, inside Chinese military laboratories, and almost no one was paying attention. China did not simply slowly catch up to the world's leading military powers. In several critical areas, it surpassed them entirely. New weapons began to appear, challenging ideas once considered unchangeable. Systems that do not merely improve the way war is fought, but fundamentally alter the rules. Today, we will look at 8 Chinese military technologies that already exist and are already in use. These are not future concepts or experimental projects. They are real. And when you reach number 1, you'll understand why military analysts around the world are beginning to worry. Number 8. Divine Eagle UAV. Stealth aircraft were designed around one simple promise. Remain invisible, strike first, and leave before being detected. The Divine Eagle challenges that promise. This high-altitude, long-endurance surveillance drone features a distinctive twin fuselage design, optimized to carry large radar arrays. It operates at altitudes exceeding 25 kilometers near the edge of the stratosphere, an airspace where most conventional aircraft cannot operate effectively. Instead of trying to defeat stealth technology with raw power, the Divine Eagle takes a different approach. Its radars operate at lower frequencies, reducing the effectiveness of stealth shapes and coatings. While these radars lack the precision of fire control systems, they excel at detection and tracking over vast distances. With endurance exceeding 10 hours and the ability to continuously monitor enormous airspaces, the Divine Eagle complicates the core advantage stealth aircraft were built upon. Stealth no longer means invisibility. It becomes conditional, and that shift alone links perception directly to movement, and the robot was trained on thousands of hours of human motion data. It can walk at speeds up to 2 meters per second while absorbing shock through its feet to maintain balance. Behind all these humanoids, researchers are also rethinking the mechanics that make movement possible in the first place. At Harvard SE's engineers developed a new robotic joint design inspired by the human knee using rolling contact joints. These joints use pairs of curved surfaces that roll and slide against each other connected by flexible elements. The team created a method to mathematically optimize the shapes of these surfaces based on the forces and tasks the joint needs to perform. This means the joint itself helps direct energy efficiently, reducing the need for oversized actuators and complex control. In testing, a knee joint designed this way corrected misalignment by 99% compared to a standard joint. A two-finger robotic gripper built using the same approach could hold more than 3 times the weight of a conventional design using the same actuator input. Applications range from exoskeletons and assisted devices to more natural humanoid robots, and even biomechanical studies of animals. And finally, in the US, Westwood Robotics is tackling another big challenge, getting humanoids to work while they walk. Their TICE Gen 2.5 robot runs on an AI-augmented humanoid operating system called AOS, which tightly integrates perception, planning, and control. Most humanoids today stop moving before they manipulate objects. Themis is designed to do both at once. Its whole body location controller uses sensor fusion state estimation to maintain balance while the arms handle objects. A navigation system built on multi-layer mapping and semantic understanding helps it plan paths while recognizing its surroundings. The interaction system is powered by an object-centric vision action model, or OCVM, which links visual perception directly to. And that shift alone forces a reevaluation of decades of air power strategy. Number 7. DF-21D Anti-Ship Ballistic Missile. Aircraft carriers have defined naval power for nearly a century. Their strength lies in range, mobility, and the assumption that they can operate safely beyond the reach of land-based threats. The DF-21D was designed specifically to break that assumption. Launched from deep inland, this missile follows a ballistic trajectory, exits the atmosphere, and then descends toward its target at hypersonic speed. What sets it apart is not just its speed, but its guidance system. It uses a combination of satellite tracking, over-the-horizon sensors, and mid-course updates to strike moving targets at sea. With an estimated range exceeding 1,500 kilometers, the DF-21D forces carrier strike groups to operate farther from contested coastlines or invest heavily in layered missile defense. Even if intercepted, the mere existence of such a system reshapes operational planning. Naval dominance is no longer about proximity, it is about risk tolerance. Number 6. Harbin Z-20 Helicopter. At first glance, the Z-20 resembles the American Black Hawk. That similarity is not accidental, but the differences lie in what the helicopter was designed to endure. China optimized the Z-20 for high-altitude operations, particularly in regions like Tibet and the Himalayan Plateau, where thin air severely limits helicopter performance. Its domestically developed engines are tuned to maintain lift and payload capacity where many other helicopters struggle. The Z-20 can transport fully equipped troops, conduct medical evacuations, and perform assault missions at altitudes above 6,000 meters. It also features modern avionics and electronic warfare systems, allowing it to operate in hostile environments. Rather than redefining global helicopter design, the Z-20 solves a very specific strategic problem, giving China reliable air mobility in terrain. Then over in Shenzhen, another humanoid grabbed headlines for a very different reason. Chinese EV maker Xpeng brought its iron humanoid robot to a shopping mall to show off progress ahead of a planned 2026 mass rollout. The demo started strong. Iron performed a choreographed catwalk, interacted with spectators, and stood on stage next to a child designed to look friendly and approachable. The robot's motion system includes a 5-degree of freedom human-like spine and a sophisticated hip structure that improves balance and fluidity. Under its outer suit is a 3D printed lattice fascia layer that mimics human musculature. This layer helps dampen vibrations and smooth out jerky motion that's common in bipedal robots. The goal is to make Iron feel less like an industrial machine and more like something that belongs in public, even retail environments. Then after completing a smooth walk, Iron lost balance while standing still and fell backward. A staff member partially broke the fall, and the robot ended up face down on the stage. Staff quickly removed it, made adjustments, and later brought it back to interact with children, asking trivia questions. The next day, it stayed strapped to a support frame and focused on educational interactions, instead of walking. Despite many earlier flawless demos, the fall dominated online discussion and became a trending topic across Chinese platforms. Technically, Iron is built to match adult human scale. It stands 178 centimeters tall, about 5 feet 10 inches, and weighs 70 kilograms or 154 pounds. It has 62 active joints, and each hand offers 22 degrees of freedom, allowing it to handle both delicate and bulky objects. A curved display wrapped around its head acts as a dynamic face, changing expressions as it communicates. Power comes from a lightweight solid-state battery for longer operation and improved safety. Processing is handled by 3 Turing AI chips, delivering 2,250 trillion operations per second. Xpeng's Vision Language Action System. The question is no longer whether robots can move like us. It is whether they can exist among us in a way that feels natural. 47.4 degrees Celsius, which is minus 53 degrees Fahrenheit. In those conditions, batteries struggle, lubricants thicken, plastics get brittle, and most robots are not designed to operate. Yet, the G1 walked more than 130,000 steps across a snow field while tracing the shape of a Winter Olympics emblem that measured about 186 m long and 100 m wide. That's not just a straight line walk. That's precise path following in brutal weather. To survive that environment, engineers modified the robot from its standard setup. They dressed it in an orange insulated puffer jacket and added improvised plastic covers around its lower limbs to protect joints, actuators, and battery systems from freezing. Positioning relied on China's Beidou satellite navigation system, giving centimeter-level accuracy. Onboard adaptive path planning algorithms helped the robot maintain stable movement across uneven, icy terrain. The G1 itself is relatively compact for a humanoid. It stands about 127 centimeters tall, around 4.22 feet, and weighs roughly 35 kilograms or 77 pounds, depending on configuration. It uses between 23 and 43 joint motors with maximum joint torque reaching 120 Nm. Sensor-wise, it carries 3D LiDAR and Intel RealSense depth camera and a noise-canceling microphone array for voice interaction. Power comes from a 9,000 mAh quick-release battery that delivers up to 2 hours of operation and supports fast battery swapping. An 8-core processor controls the joints, allowing walking speeds of about 6.5 feet per second, which is roughly 4.5 miles per hour. The robot runs on Unit's Unifo LM model, a unified, large model for robotics, and uses reinforcement learning for motion control and task execution. Originally introduced in May 2024 as an entry-level humanoid, the G1 starts at 9,000 renminbi, around $14,240. Unitree also reported shipping more than 5,500 humanoid robots in 2025, which shows serious scale.